43 quintillion possibilities. That is how many ways this cube can be scrambled. This is one of them. One photograph. 2. That's all I gave to the AI. And I asked it, solve this. That is how my weekend experiment with Claude began.
Now, I think you might be thinking this is a cube video, and it is not. So this was a little weekend experiment that taught me more about building the real world AI systems than most of my serious projects. By the end of this video, I will share 3 lessons that you can apply directly to enterprise AI work. So stick around. A couple of years ago, when ChatGPT got the vision models and the multimodal capabilities, I had tried this exact experiment and it failed badly. So I had parked this idea. So in the last weekend, I thought I will give it a try with the latest Claude Fable 5 model. So my prompt was deliberately ambitious. Solve this cube from 2 photographs, fewest moves possible, ideally within the God's number. A quick aside for the non-cubers. So what is God's number? God's number is 20. Any cube, no matter how scrambled it is, can be solved in 20 moves or fewer. And that is called the God's number. This is not a hypothesis. This is mathematically proven. And proving that took 35 CPU years of computation. So yes, the prompt was cheeky, but Claude replied, I can certainly try. Optimal may not be possible, but let's see. So I uploaded 2 photographs showing 3 faces each. Now, I should mention I am a hobbyist cuber. I have a large collection of twisty puzzles, but my favorite is still classic 3x3. And I solve it with a method called CFOP. I used to do speed cubing, but these days it's more like the passive solving. So that means the hands will solve the cubes before the brain gets involved. Think of it like typing. So you don't search for the keys on your keyboard. Your fingers just know. You have developed that muscle memory so that you don't have to think about how to solve this. So that is how I solve 3x3 cubes these days. So this weekend experiment was not about finding optimal solutions. I wanted to see how AI understands the cube. And what I ended up learning is how AI sees the cube. When I gave this prompt, the very first move was odd. I had given 2 photographs showing 3 faces each, so that Claude knows all the 6 sides of the cube clearly. And I was thinking so. But Claude pushed back on my photos. It said it would be better if you upload all 6 faces individually. So I was thinking corner shots show the 3 faces at once. The adjacency is right there visually. So why do you need 6 individual photos? And if I were to do this, then I have to explain what is on the top, what is next. But here, this is very clear, is it not? It still insisted. It said it preferred the faces one at a time. So I thought, okay, let me give it. And I understood. Claude is able to recognize almost every sticker correctly. Started asking many questions that I, as a cuber, found it very strange. It was asking which face is on the top. Did you rotate the cube? Can you confirm the orientation? These kind of questions it started asking me back. And at one point, it even asked a silly question. What was the color of the center sticker of the blue face? I was like,
are you serious right now, bro?
So if you are talking about the blue face, the center is obviously blue. As a cuber, right, we know in our mind very well that if I hold a cube like this, if you put white on top, green in the front, and orange will be on the left. You can also see the opposite side. The white opposite is yellow. And this relationship never changes, right? You scramble it any number of times. If you orient as white on top and green on right, orange will be on left always, and yellow will be opposite white. How many ever times you scramble, this relationship never change. The corners move, the edges move, the centers don't move. That is a basic cube theory. And I know Claude knew this because I have discussed cube theory before with Claude. And so I know that this was not a knowledge problem. A 3x3x3 cube has 43 quintillion possibilities of configurations. That is roughly 10 times the number of seconds since the Big Bang. So AI cannot memorize the cube states that I knew. So it has to reason about what it's seeing. So my suspicion was it was failing at building a stable 3D model from the flat photographs. So in the next chat, Claude confirmed it. It said, I have been doing a lot of 3D mental rotation to align those photos. The kind of spatial reasoning is exactly I am most likely to make a silent error. Mixing up left and right after a rotation is a classic mistake. I loved that and I agree. Suddenly the problem was obvious. It was not solving the Rubik's Cube. It was doing a mental 3D coordinate transformation, a completely different problem. So at this point, I was even thinking this is also going to be a failure. Probably Claude is hallucinating. And after several minutes, Claude did something that changed my confidence completely. It did not announce the solution. It said, here is the reconstructed CubeNet. Please verify it against your physical cube before trying the moves. That was the moment because Claude had converted a fuzzy perception problem into something I could check sticker by sticker. So I compared it with the real cube. It was perfect. And in that moment, something clicked. The struggle was never about solving the cube. It was about two of us agreeing on what the problem actually was. And here is the thing, right? Once the cube state is correct, the rest of is just mathematics. Because there are proven algorithms. It's been there for decades. Claude fed this notation to the algorithm and it came out with a solution. 21 moves. Just one move above the God's number, which is fine because I knew that it used a faster algorithm called Kochi-Emba's algorithm. So I applied these moves into the physical cube and it got solved. So of course, I could not stop here. So if the orientation was the bottleneck, could I make the orientation problem trivial? That was my next challenge. So I asked Claude to build a helper, a simple HTML page, so that I can click the stickers and pick the colors. In a couple of iterations, Claude built that HTML helper for me, which was perfect. So then I wanted to push it further. So I asked, can I make this as a 3D visualization so that I can examine the scrambles easily? And again, it took a couple of iterations. The interactive 3D cube page was built for me. Then I pushed this a little bit further because it can work on a 3x3. So why not on a 4x4x4 or a 13x13x13? And why not on a cuboid? Cuboids are those cubes which can have shapes like 2x2x3 or 3x2x4, these kind of rectangular prisms. And why not a pyramids? Pyramids is that pyramid shaped cubes of various layers. Because the architecture existed, each new shape, each new puzzle was able to generate at runtime. So now, do I really need this helper for me to solve a cube? Probably not, because I can solve cubes easily. But for a bigger cube, for example, 13x13x13 kind of a cube, yes, I could get some help from AI if I have to solve this within a few hours. If you want to solve patterns like cube in a cube in a cube, or if you want to make cube art, for example, if you want to make flag painted in stickers, working out those states by hand could be tedious, even though it could be a mental challenge. With this helper, it can be easily done. So then I came up with the next idea. The color picker worked, but I was still clicking around by hand, right? So can this be automated? I did not want AI to read my photos at runtime. And I decided to teach Claude how it should do this. Take this photo, detect the 3 visible faces. And I found Claude is again struggling to do that. I said, fine, let's go small step at a time. I told, erase everything in the image except the top face. And that's when I saw it. It was erasing. Erasing was a bit fuzzy and approximate. I think it was using some vision model segmentation, the image editing by approximation. Then it kind of clicked why it preferred the 6 photos instead of these 2 photos of 3 sides each. Because reading a flat face photo is a pattern matching and reading a corner shot is geometry. So Claude was actually asking me to do the geometric pre-processing. But this was the frustrating part, right? No matter how carefully I explained, it would not abandon that approach. It kept repairing that same approach. And I realized patching this solution was wrong at its foundation. So I tried something counterintuitive. So I I opened a completely fresh conversation. And this time there was no context. There was no history of failure, no Rubik's Cube challenges. And I asked the exact same question. Here is the photo. Detect the 3 visible quadrilateral faces. And it did that almost immediately. And then we further iterated that into an HTML page that I can repeat over any other photographs of nearly the same angle shots. So this was a geometric solution, a better one. And I knew that using HTML color pickers and got a system built with that approach. So that reminded me of something very human. Sometimes we are so invested in fixing yesterday's idea. So I'm going to ask Claude what happened. Hey, Claude.
Hey, Ranjit.
I gave you 2 photos of the scrambled cube and you read the colors easily. You asked me for 6 individual face photos instead. And why was it?
Quick, direct, honest answer. Those corner shots require 3D mental rotation. I'd have to figure out perspective. Which face is which? Correct for the angle. Face on photos are just a flat grid, pure pattern matching. That's where I'm strongest. So I was asking you to do the geometric work for me. I knew I was weak at spatial reasoning. I just didn't have the words for it yet. Even with the flat photos, I still had to connect them, understand how face 1 relates to face 2, which edges touch, the 3D structure. That's where the orientation questions came in. The individual photos removed the perspective problem, but they created a new one. I had to assemble the cube state from 6 separate 2D images. Without that spatial context happening automatically, I kept asking clarifying questions. It was pattern matching hitting its limit.
Thank you, Claude. Thanks for the clarification.
You're welcome, Ranjit. This was a good conversation, honestly.
So somewhere along the way, I realized I was not building a cube solver anymore. It was learning how the real AI systems get built. What looked like one problem was actually a few smaller problems. Detect the cube, find the faces, locate the corners, correct the perspective, recognize the colors, and orient the face, generate a canonical notation, and finally invoke the solver. Individually, none of this is magic. Together, they do something that feels like magic. And this pattern applies to many of our real-world problems that we are trying to solve with AI. So with deterministic pre-processing and canonical representations, with AI reasoning and a deterministic execution. So, what did I actually learn? 1, you can build an intelligent system with AI that uses no AI at runtime. Sounds like a contradiction, but it is not. It is all in the architecture. My color extractor was built with AI, but runs with none. Pure rules, pure geometry. The rules give you what models cannot promise: predictability and reliability. Now, building the systems like this used to be expensive in the past. With AI as your engineer, it is incredibly cheap. Goal is not to make AI solve everything. The goal is to keep shrinking the part AI has to guess. There is a classic framework captures this. Every problem has 4 parts: known knowns, known unknowns, unknown knowns, and unknown unknowns. The known knowns, coordinate transformations, grid splitting, Kochiyamba's algorithm, those were never AI problems. They are software engineering. Solve them deterministically. Known unknowns, how do I infer orientation from 2 photos? We know what success looks like, but we just don't know the method yet. That is where AI can help us. The unknown knowns, the things that you knew so deeply, but you forgot to say them aloud. Centers never move. The blue faces has a blue center. Things like that. Say them out loud. And the last, the unknown unknowns, the 6 photo request, the fresh conversation trick. You cannot always plan for those. You can only find them by experimenting. But the moment you spot one, it stops being an unknown unknown. It becomes a known unknown, something that you can actually work on with the help of AI. And since AI makes experiments cheap, the unknowns drain faster than ever, from unknown to known to code. And every deterministic step you extract is one less thing the model has to guess. 2, understanding the problem is often the solution. This is a thing that I relearned by this experiment, right? And this is also true when you work with AI. The most important work is making it understand your problem. The turning point of this whole experiment was when Claude handing me the cube net and saying, "Hey, check this before you trust me." That net was the proof that we finally understood the same problem. Once we agreed on what the cube looked like, The solution was almost there. So build your AI systems around checkable intermediate artifacts. A verifiable representation is proof of shared understanding. And number 3, sometimes the best prompt is not another prompt. It is a fresh conversation. Accumulated context can be an accumulated baggage. Can AI solve a Rubik's Cube from 2 photos? Yes, this and most other problems AI can solve. But that was never the interesting question. The interesting question is, do I need AI to solve every problem? For me, the smaller ones, they stay mine because I enjoy the journey and I'm not letting AI spoil that joy. But this one, so yes, let's solve together because I'm not going to spend a few hours in this weekend for fixing this beast. Thanks for watching.